Thank you.
Okay, thank you. Thank you, Alexander, for having me. I work for Feed Design Lab. We are the Research and Education Center for Innovation and Sustainability in the feed industry. And we have our own facilities, a pilot plant to do technological research for feed. And feed means livestock, so poultry, pigs, cows, but also pets, dogs and cats, and aquaculture feed. We also do education, so we have a lot of trainings going on, more on the technological part of making feed, and we do participate in projects or start projects ourselves, which are all in the feed industry. My name is Ageeth van der Lee. I work as a project coordinator. My background is nutritional research in poultry and pigs. You see my email address. If you have a question, just email me. And today I'm going to talk about the use of dry and wet algae in feed. We do a lot of application research, and the Ageeth project at Feed Design Lab just fits in very well. What did we do at Feed Design Lab? We did a literature research on algae who are in this project. We did some research works on algae in our pilot plant, so about a technological application in feeds, and also using those feeds in animal tests to see what the effect on animals will be. We started working before the Interreg project started already on algae. Feed Design Lab was founded in 2014. In 2015, we did an exploration test just to find out if you use algae in broilers, if performance is still okay. That worked out well. And to 2017, we performed an in vitro test. We produced feed with 25% of a protein source, and those protein sources were soybean meal, fish meal, black soldier larvae, and algae. We tested that in vitro on digestibility. That also worked out well. So we were interested to cooperate in this Ageeth project. And one of the first experiments we did in our pilot plant was with dry algae. It was in November 2018. We produced feed for pigs with 2% of Chlorella vulgaris and tried to find out how to process that in a pilot plant. So what do you need to do to mix it correctly, to process it correctly in a pellet in this case, but also in different forms. So here you see a sample of the pellet we produced. What you can do when you have dry Chlorella vulgaris is also mix it with water. So you have a product you can spray on a product. So you don't mix it in and process it. And processing means you can have temperatures between 70 and 90 degrees Celsius. Sometimes that might be a little bit too much to have all the good properties of algae still in the product. So another way of doing an experiment is making it liquid and spray it on a product after the heat part of the processing. And that's what you see up here. We also did some experiments with wet algae mix. That wet algae mix was coming from the Forschungszentrum in Jülich. It was frozen, so we defrosted it and then we mixed it so it was totally liquid. And you see that on the picture on the left. And then we dosed that liquid product in the conditioner just before making an extruded kibble from it. And that the product just after extruding you see on the picture in the right. So you can also see it's quite green. That wet product was also used, not using the heat step, but using it in the vacuum coater, so after the heat step. And here you see you have a very airy kibble, but the algae product was only on the outside. It's not getting into the kibble, which we expected. So we did some extra research afterwards to have that realized too. We did that feed production with the dry algae, and there was a little bit of feed left over from that experiment, and we found it was a good idea to check that in piglets. But the amount of feed was not that big, so we could only check for 1 week in piglets of 20 kilogram, and we had 4 replicates of pens of 10 piglets. But that's not a good, that's a normal, not a normal setup for an experiment, but just to check if it did work out. And the results were, we still had healthy pigs, and we didn't expect it, but only testing for 1 week, we had better growth for the animals. And that was very surprising. I must say we didn't publish it because the setup of the experiment wasn't ready for that. What we did with the feed from the experiment with the dry algae, we performed a lot of analysis in the algae and the feed samples. So the physical properties were checked, the chemical properties were checked, and also the microbiology analysis was performed, and they were all fine. So we learned a lot about how to use algae in feed. We also checked the literature on effects on health with ruminants, with poultry, and with pigs. And we did that for algae strains which were in this IDEA project. What you see for ruminants, there are not many researchers, literature found for ruminants, but also the effects are not always very positive. In poultry and pigs, there are much more good results found, and not only on performance, but also on effects on immunity or antibacterial effects or anti-inflammation effects. And in pigs also on reproduction. So that looks very promising. If you are interested in having this literature research, you can send me an email and I will send it to you. So I already told about the exploration part we did, the in vitro part we already did, and we thought it's a good idea to do a challenge experiment in pigs, because we have seen algae has also positive effects on health in animals. And doing a challenge experiment, you can make it very clear if you give them a challenge how good algae might work as an additive in feed. And an additive means you're dosing 0.5% in the feed. So not a lot of product. So you don't use it as a replacer for other protein components in the feed, because that's still much too expensive, but you only go for a small dose and try to find out if health is positively affected. Unfortunately, we made a nice plan, but we needed some co-financing and that wasn't found, so we had to stop that. And then we had a plan B. We wanted to check if health promoting effects of algae are found in dogs. Therefore, we are now setting up an experiment with 1 treatment a positive control, 1 treatment 0.5% of porphyridium, which is already washed and coming out of this project. So these products are grown and used in this project, and 1 treatment with 0.5% of chloromonas, which is disrupted also from this project. We're going to check the algae products and the feed analytically before we start the experiment, of course, and the results we expect are on performance. So do the dogs accept the feed and how is the feed intake? We also check the manure score, and we also check about IgA in manure and to see if we have anti-inflammation effects. So we hope to find an immunity response. And we hope to find also something which is very good for dogs and to help them out for a better health. Thank you for your attention and hope to have some questions later on.
So thank you, Ageeth, for your